We loaded in our data, and here's my first solution for calculating the percentage of fraudulent data. First, from our transaction data frame, I'm counting up the occurrences of data points in each class using .value counts. This gives me back an array of counts. I can get the fraudulent counts from counts 1 and the valid counts from count 0. Then to get the fraction that I want, I just divide the fraudulent count by the total count here. Then I'm returning that fraudulent percentage and running my test cell below. I can see that out of about 285,000 data points, about 500 are fraudulent, which makes up about 0.17% of the data. So this is not even a whole percent that's labeled as fraudulent. Now, on the one hand, this is good. We don't want this person to have experienced many fraudulent transactions, but it will be challenging data to learn from. Many algorithms assume that we have a relatively even distribution of data among the classes, and we'll get into ways to manage a class imbalance like this later on. Next, I wanted to split this data into a training set and test set for evaluation later. So here's my solution for splitting the data according to a passed-in train frac. First, I'm grabbing my data frame of transaction data and converting it into a matrix using df.esMatrix. This will make it easier for me to use NumPy functions to shuffle and split this data. Next, according to my passed-in random seed, I'm randomly shuffling all of the data in this matrix. And here I'm getting the train size, the amount of training data that I want to keep. This is going to be the number of rows of data in our matrix times the train fraction that's passed in. Since this fraction is a decimal value, I'll actually want to cast this to be an integer type. So I'm casting to an int because our data is discrete. That is, I can't have half a data point. So this is going to round down any float value, and this is okay behavior for such a division. Now this train size will be the index of the row that I want to split my matrix data at. So here I'm getting my train features up until that index, train size. And I know my class labels are in the last column of the data frame, so I'm not including that in the features here with -1, not the last column. Then here I am getting that last value to save as my class labels. Then I'm doing something similar with the test features and labels. I'm getting the remaining rows of data, notice the placement of train size before the colon here and after here, and then here getting the last column of test labels. Finally, I'm just returning all of these in a specified return order, training features and labels and test features and labels in separate tuples. So this completes my function. Now I can call this function in the next cell and test out the shape. I'm leaving a default split of 0.7 for my training data, so 30% of my data should go to test data. Then I have a few tests on here that check that I have the correct shape for each of these features and that all of my labels are indeed zeros and ones. This cell prints out the number of training points that I generated, about 200,000, the number of test points, and a test first item and label. I should see 30 features in this first item and a single class label. 0 indicates a valid transaction. So now that we have all our train data and test data, these are almost ready to be fed into a model. So next I'll outline how to build and train a binary classification model.